Alright, hello 7th graders, how's it going? This is Mr. Miles coming at you again with another podcast. This one is actually going to cover lesson 3, the first chapter. I sure hope you're watching this, because this is what the test is on, but you're hearing my voice and obviously you're already watching it, so that was kind of a redundant statement. So, let's get started then. What we're going to talk about today, we're going to talk about how heat is transferred. So hopefully you have your book with you. It might help you with this lesson especially to follow along. So if you turn to page 18, open up your book. And we're going to look at the top. And it says, how is heat transferred under the key questions? And then how does convection occur in the Earth's mantle? So the first 3 vocab words that we're going to run into is we're going to run into these 3. Radiation, conduction, and convection. So you're going to see these words come across on page 19. So, as you look at radiation, the definition talks about how heat's transferred through waves. Heat's transferred through waves. So you can see in the picture the person standing there, they're smiling, and they're letting the waves, the heat waves come and hit their face. And so this is called radiation. So the light rays come in waves and they hit the face, and that uses radiation. You're familiar with other terms of radiation, and if you remember my example of what I was talking about in class, the longer the wave, the less dangerous it is for you. You know, the faster the wave, the harder it is for you. And what I was saying in class was the reason it's more dangerous is because you have your cell. You guys all remember cells from last year especially. And you have the little nucleus, and inside the nucleus you have DNA, and DNA is pretty much telling the cell what to do, how to build the person up. Now, if you have long wave radiation kind of passing through your body, just think of it as something like calm. So let's say you guys are doing work, and Mr. Miles is standing above you, and he's like, oh, good job, you're doing a great job. Don't worry, long, casual, nice and slow moving. Now, the kind of radiation that's bad for you is up and down really fast radiation. The wave's going to be really short and really quick. So that would be like Mr. Miles standing next to you going, oh my gosh, you need to do your work. If you don't do your work right now, then you're going to be in a lot of trouble, and I need you to do your work right now. You're going to have a lot harder time. And the same thing with the cell, as that fast, those quick waves are passing through the cell, it has a really hard time concentrating and do the work it should, and that's where you get those mutations. That's where it can lead to cancer. So that's a little bit more than you really needed to know, but I thought you'd enjoy that little tidbit. So that's radiation. It's heat transfer through waves. The next one you have is conduction. Now conduction is heat transfer through contact. You need to have direct contact from surface to surface. Remember, that's the thing I was telling you about. If you have your boy and he's walking and it's cold outside, and there's the girl, and let's say she has bad circulation, she's cold all the time, and she goes and she holds his hand, she goes, oh, you're so warm, and she starts to feel warmer. Well, that's surface to surface contact. His hand is warm, and because she's touching it, she is now becoming, at least her hand is becoming a little bit warmer. Now the last one we're going to run into, so remember this surface to surface contact, the last one we're going to run into is convection, and that's using a fluid as an intermediate between the heat source and what's actually getting heated up. So it's like the same, so the way to think of this is if you have a pot, say this is fire down here, and here's your water. If you put your hand in the water, it's going to burn your hand. That's because the heat source, which is the fire, is using the liquid to actually transfer through and then actually burn you. Now, if you wanted to do conduction, then you'd actually touch the actual heat source, and then that's what's going to burn you. So convection is using a fluid. Now, keep in mind, fluid can also be talking about air. If you want to take a second, hold your hand out and blow, not like that, like if you're whistling, but just like, I don't know, with like your mouth open, like, trying to heat up your hand. Kind of like that. You can feel the heat on your hand, and the reason you're feeling that is because it's using the air to warm it up, and it's using convection because there's no direct contact. The heat source, coming from your mouth, isn't directly touching your hand, but it's using the air as a fluid to heat it up. Now, we're going to use that convection definition. We're going to go a little bit deeper. So as we turn to page 20. Now, when we're dealing with density, which is the first thing, you're dealing with, say you have 2 balloons. 2 balloons. Alright? You have one balloon that is very cold. So what's going to happen is when something gets cold, remember we talked about this, all the molecules are want to stay really close to each other. So the balloon's going to be, kind of wrinkly, It's not going to be as big, so it probably won't be about that big. Now, if you have one that's a little bit warmer, well, then all the molecules are going to want to spread out. Because remember, as things get warmer, they want to be able to move more. So that's little movement lines. They want to move more, so they need more space. So this balloon is just going to be near about ready to pop. So it's going to be a lot bigger than this balloon. So this is the big one, this is the small one. So density. So as things heat up, they want to expand. Also, what they want to do as they heat up and expand, they become less dense, and so they want to rise. You know the saying, heat rises? This is why they tell you whenever there's a fire, they want you to get on the ground, because all that hot air wants more movement, so it needs to expand, so it's going to go up. It's going to become less dense, and heat's going to rise. The same thing I was talking about is in your house. The hottest place in your house is going to be your attic. So we're looking down here. So we have all our water inside the pot, and you have your fire down here. So what's going to happen is this water is going to be hotter than this water, and so the heat's going to want to rise and come up. But then as it gets here, it's going to cool. So unless it, if it evaporates, it's going to float away. But if it doesn't evaporate, what it's going to want to do is then that cold, don't say cold, but cooler, it's not as hot as this water, is going to want to come back down here, because as it gets dense, it wants to sink. So it's going to go like this. And like I was saying in class, a really cool thing you can do is if you're ever making macaroni and cheese, wait for the water to get boiling and then just let it stir itself. Because the macaroni will start getting stirred because you'll get convection. And you're going to get the warmer water rising up, and then as it gets less warm than this, it's going to drop back down. The same thing is always happening inside the earth. If you look on page 21, you can see that inside the earth, so this whole thing right here, this is your core. And this right here, oh, that's terrible. Here, let's erase that, redraw that one. So I don't want to make you guys go blind from like terrible drawings. So, oh, and my thing's freaking out. There you go. And this right here is going to be your mantle. And the same thing's going to be happening because it's hotter down here. And so what's going to happen is the heat's going to want to rise up. And keep in mind, it's not going to leave its zone. It's going to want to rise up, and then it's going to want to drop back down as it moves away from the heat source and becomes cooler. So it doesn't happen outside of its zone. So that's the inner core, and then outer core is going to be doing it all by itself. It's going to want to rise up. It's going to want to drop back down, and the mantle is going to do it by itself. It's going to want to rise back up. It's going to drop back down. And this transfer of heat and energy also transfers. So remember, inside the outer core is actually liquid. So it's actually a direct fluid, like as in a liquid. And so it's going to be able to move. Even the mantle, even if it's made of rock and it's solid, it still does the same thing. Now keep in mind, like I said, it does take place over a long period of time. It is extremely slow. You can't watch it and watch the rocks moving. What is the hotter rocks, oh, my voice is kind of cracked, is the hotter rocks heat wants to rise. It's going to slowly work its way up to the surface. But then as it cools down, it's going to want to drop back down because it becomes more dense. That all goes back to the density. As something becomes cooler and more dense, it's going to want to sink, versus if it expands more and becomes less dense, it's going to become hotter and it's going to want to rise. So that vocab covers the last of lesson 3 and pretty much goes over all the main parts of it. Now again, I don't know if I even mentioned this, sorry if I didn't. This means this is a convection current. And so that's what's taking place in the earth. You're having a convection current, where you're having that mixing, where the heat's being able to transfer. Because you may have asked, sure, it's getting heat from the earth, but how is it getting it? So it's having this cycle, and this helps heat up this part, and this helps heat up this part. I hope you guys enjoyed this. Again, if you have any questions, feel free to email me, and then we can go over it. Make sure you do it soon, because the test is coming up on Wednesday. All right, you guys take care, and until next time, I'll see you later.